When we hike through the countryside or gaze at a mountain, we have the feeling that the landscape surrounding us is unchanging. But is that really the case? We live on an evolving planet, which has been transforming for millions of years, and it continues to. And don't forget that what we see on the planet's surface is just a small part of the whole. Under our feet is a wide variety of geological materials, rocks, sediments, minerals, and more. Their presence, composition, characteristics, and formation is what geologists study, and their graphic representation is what is known as a geological map. A geological map takes a profound look at which materials crop up on the Earth's surface and how each of these elements is arranged. In other words, the map is a representation of the geological architecture both above ground and underground. This vital information allows us to make the most of mineral resources such as metals and energy sources like coal and oil. It also helps us to locate the water that has filtered into aquifers and to use geothermal energy. In addition, geological maps are important for guiding agricultural activities. But that's not all. Thanks to geological studies that are supported by maps, we can establish where natural processes are likely to occur, including landslides, earthquakes, floods, and volcanic eruptions, minimizing the consequences of natural catastrophes. Actually, geologists' work begins in the library. The first thing they do is to analyze and study any existing work that covers the area where they plan to create the geological map. Geologists need an overall view of the terrain and any variations in elevation. To this end, they use pairs of aerial photos. These are partially superimposed and used with a stereoscope, allowing for a 3D view of the surface of the area to be studied. In less complicated zones with scant vegetation, photogeology makes it possible to create a preliminary map which is quite complete, accurately pointing out faults and folds, as well as classifying materials. With this preliminary study, geologists can determine which points must be observed directly in the field because they are either complex or representative in nature. And now, the field work can begin. It's not usually possible to analyze every inch of the terrain, but geologists, guided by the observations they've made using aerial photos, follow a predetermined path with key stops known as stations. At each station, geologists identify different kinds of materials. They collect and study samples of rocks, sediments, and fossils. All of these are carefully labeled, and the exact date and location are noted. The rocks that make up planet Earth, which we can see on its surface, are quite varied. Igneous rocks formed by the cooling of molten rock deep within the Earth, metamorphic rocks transformed by the great pressure and high temperatures found underground, and sedimentary rocks formed by the accumulation of sediment in lakes, in riverbeds, and on the sea floor. Sedimentary rocks are deposited in layers of varying composition as strata, usually in a horizontal pattern. In order for them to become visible on the Earth's surface, they must be pushed upward by the same forces that create mountains through a process known as orogeny. During this process, which lasts over many millions of years, rocks are deformed, folded, and fractured along break lines called faults. Using a compass outfitted with a clinometer, geologists can measure the direction and inclination of strata and other structures. This allows them to recognize different geometric patterns and gather essential information in order to make a three-dimensional reconstruction. With the help of aerial photographs, they draw a first draft of the map directly on the terrain, marking lines between the different rocks. Their observational capacity, experience, and knowledge of other similar phenomena allow them to sketch out large areas of the map. All of this information is compiled in their field notebooks or on more modern devices, which allow further data to be entered in a geo-referenced manner. Back in the office, geologists contrast the information they have obtained with aerial images and previous studies in order to finalize the map, which may or may not be digital. Standardized symbols provide visual clues to help us rapidly identify the different types of rock that have been found: sandstone, limestone, and dolomite rocks, the age of which is shown by their color. The geological age of each rock is an essential piece of data that geologists need so they can put the events that created them into chronological order and examine the geological history of every corner of the planet. The evolution of animal and plant species and the successive great biological extinctions make it possible for us to date sedimentary rocks because of the fossils they contain. Rocks with the same fossils will be the same age. The absolute age of a rock can be determined thanks to radioactive dating. When a rock is formed, the minerals have a precise elemental composition. Some of these are radioactive and therefore become unstable over time. We know that they disintegrate in a certain time period, giving way to other elements. If we measure the proportion of these, we can find out the moment the rock was created, sometimes many millions of years ago. The geological map is not just a flat representation, it is also three-dimensional. Using orientation and inclination data for strata and faults, geologists can draw geological cross-sections and 3D models that show the spatial positioning of different materials located many kilometers beneath the Earth's surface. Once the mapping process is complete, field geologists send a rough draft of the map to cartographic specialists for validation. Once it has been approved and accepted, the map is ready to be published in different formats. Since geological science began hundreds of years ago, geological maps have served as a basic tool for geological knowledge. And this is still the case. The maps are a visual expression of the work of geologists, allowing us to learn what the Earth is like today, to remember what it was like yesterday, and to predict what tomorrow will bring. For beneath our very feet, although it may be quite slow, the Earth is changing, moving, and transforming.